for you at least once.
I'm good. I haven't noticed I had to do that. Okay.
Here's another trick.
Math. So for number 1, the range of this, so this should look somewhat familiar because the last shortcut we did had the domain, same order pairs. So for this one, we're looking for the range, which is just your y values, but least to greatest. So least to greatest without repeats, so that would be -5, -3, -2. And that's it. Number 2, you would need to start solving this. As you start solving this, distribute and combine like terms. You get that you have the same coefficient, and constant, even though they're flipped. It is the exact same thing on both sides. So from that point, you can say it's infinitely many solutions. Or you could keep solving. Subtract 3x on both sides, you get 6 = 6, and then you would see that it is also infinitely many solutions. For number 3, you needed to solve this for y. Add x to both sides, divide everything by 3, and you get y equals 1/3 x minus 1. Do we have any questions on those 3? For number 4, you had a proportion where you needed to cross multiply. Cross multiply, distribute, start solving for x by moving something to the other side and move the opposite to the other side. Opposite side of what you originally did. Divide and you get x equals -2. And then for number 5, we had to find the domain of this function. This was a continuous function. So we need to look furthest left to furthest right. Furthest left would be at -3. Furthest right would be at 1. So from -3 to +1 would be our domain. Do we have questions on either of those 2? So we have new notes on factoring today. That is going to be different from what we've talked about previously. We're not really factoring out a GCF or doing grouping. We're not using difference of squares. This is something completely different. So make sure you have these notes in front of you. They look like this.
I'll give you one.
So before GCF, we were factoring, and it had like 2 terms. Those were binomials. Difference of squares has 2 terms. It's a binomial. GCF could have 3, but that was a rare instance. Grouping had 4 terms. But with these, we're dealing with trinomials, so 3 terms. So if you have 3 terms in this format, so there's nothing in front of x squared, or it's really a 1, then you can use these. And we have to use different rules. Remember that some of this may be new, so everyone should be paying attention. And one of the rules we have to follow is anytime it is in this format, how we factor this is we start looking for two numbers that multiply to be C, and of those factors, they have to add to be B. So me just saying that doesn't really mean a whole lot. There are also rules within that, but we'll get to that here in a bit. So let's do some examples. For number 1, we need to find two numbers that multiply to be 12 and add to be 7. You may already know what those are, but let's say we didn't. We could list out the factors of 12. What are some factors of 12?
4
and
2 and 3.
4 and 3, 2 and
6
6,
and 1 and 12.
and 1 and 12. So now, of these, if we were to add the numbers together, so whatever pair goes together, so 4 and 3, 2 and 6, 1 and 12. If we add those together, which one would give us 7? 4 and 3. 4 and 3. So we could say a positive 4 and a positive 3 would give us a positive 7. Once you find those two numbers, you're going to write this in factor form. Actually, let's... Okay. So in each of these, you're going to have an x in the beginning. And the two numbers you just found, you're going to put in your set of parentheses. Does not matter if I put plus 4 here or here, but this would be plus 4 plus 3. Just to make sure that works, we could multiply this back out. If I were to multiply this back out, x times x gives us x squared. X times 3 gives us 3x. 4 times x gives us 4x. And 4 times 3 gives us 12. If I combine those like terms, I get 7 again. So I can say that works. Ready?
For writing the answer, do we just put the words in parentheses?
Yes. And that is your final. Everything else is checking your work. So far, do you have any questions on this?
So the one that you have it highlighted is the right answer?
Yes. It's the final answer.
I can do this in my head.
A lot of these you can't. Some of them have bigger numbers. And when we get into the negatives, that might make it a little different.
Oh.
So number 2, we need two numbers that multiply to be 20 and add to be 9. Yes? So if you start thinking about the factors and you know them really well, really you need to know them really well. But if you don't, you can always look at your calculator, start dividing 20 divided by 1, 20 divided by 2, 3, keep going until you have all of them. But if you know your factors really well, then you don't need to do that. I'm still going to list them really fast. If you did have to list them, you can also start eliminating some. So if you know you need to add them together and they need to be 9, well 1 and 20 wouldn't work because no way I'd add them together and I get 9. 2 and 10 is close, but it's not 9. So again, I can eliminate that. But 4 and 5 is spot on. This would need to be a positive and a positive. So my two factors would be x plus 4, x plus 5.
It doesn't matter if you put the 4 and the 5 first.
That part does not matter. Do we have any questions on this so far? There it is. Let's skip down to number 6. We're still looking for two numbers that multiply to be 1 and add to be 2.
1.
1 and 1. 1 times 1 gives you 1. 1 plus 1 gives you 2. So if it helps, write those factors off to the side. That way you know those are your numbers. They're both positive. So your two factors would be x plus 1, x plus 1. I'm sorry, these are y's. And these were n's. I just like us. That's all. If you have a case like this where it's the exact same thing, you could simplify that a little bit and say y plus 1 squared. Because that would be the same. So don't do what I just did. Make sure you have the right variables. Okay. So all of those examples, we had a positive and then a positive, so both of our factors were positive. Now we're going to deal with some examples where that is not the case. So starting with number 7. With number 7, we now have a positive and a negative, so that's going to affect our factors when we write them. And when you do this, I would think about what times what will just give me 18 and then worry about the negative afterwards. So what are some factors of 18?
1 and 18.
1 and 18. 2 and 9. I think you guys said the same thing. 3 and 6. Now, we know it's negative 18. The only way we could get a negative is if one of the numbers or one of the factors is also negative. So you have to think, could I make this one negative and add 18? Could I get positive 3? No. If I do it the opposite way, then still no. 2 and 9, would either of those work if I made one negative? No. 3 and 6 would definitely work. We just have to figure out which one would be negative. So negative 3 plus 6 would give us a positive 3. So once you figure out which one's negative, which one's positive, then you can put them in your factors. X minus 3, x plus 6. Doesn't matter the order. You could put x plus 6 first. I'm going to distribute this back out so we know that it works, and then I'll say something else about this. So here we have x squared, x times x. X times 6 would be 6x. 3 times x would be negative 3x. And then negative 3 times 6 is positive negative 18. Sorry. And if I combine those like terms, I do get x squared plus 3x minus 8. So if you have a positive and a positive, both of your factors are positive. If you have positive, negative, one of your factors is going to be negative, and the smaller number is going to be the negative. That rule would always apply for these. I really like X, apparently. It's fun.
So if I put X in the side, should we not make?
You'll get less points taken off because clearly I'm already making that mistake, but I'm just going to say not your variable.
Yeah, that was a little understandable, right?
Right. Right. Okay. Do we have any questions on that one? Let's do another one. Number 10, similar. We have a plus and a minus, so one of our factors has to be negative. The smaller number will be the negative. What are some factors of 54?
6.
9 and 6. You're right.
Yeah.
Now there are others, but 9 and 6 are going to be the ones that work. If we make the smaller of the two negative, which is 6, positive 9 minus 6 would give us positive 3. So this would be S plus 9 and S minus 6. Yes.
Is our next test going to be like almost?
It's all factoring, yeah. Okay, so we've talked about positive, positive, negative, positive. We are going to do a couple examples where it's now positive, negative, but there are none on the front page. So if you turn it over to the back, there are a bunch of practice problems. We're going to do a couple of those. I think I started at 7 and 8. So we're going to start at number 7, and then do number 8, and then we'll go back to the front. Just a guess, if we have a positive, if we have a negative and then a positive, what do you think is going to happen with our factors? Both positive, both negative, one positive and negative? What do you think? I would say keep that in mind because that'll help you determine both negatives. Okay, and we'll see here in a second. All right, what are some factors of 8?
Wait,
Sorry. No, you're good.
It's going to be 2, 4.
2 and 4. And then 1 and 8. But yeah.
Oh, yeah.
Okay. So if we have these factors and we need negative 6, it needs to add or subtract to be a negative 6. The only way we can multiply to get a positive is if we multiply 2 positives or we multiply 2 negatives. So whoever said 2 negatives, you're right. So instead of making this, making one negative, we'll make them both.
Couldn't you do 4 and 2?
Mm-hmm. And that would give you your negative 6. So we have y minus 2 and y minus 4, not 6.
Wait, so if you what happens if you did 2, like negative 2, then plus 4? Now, now has to add the 6, and you do 2 and 4.
Uh-huh.
What will the answer be? Just 2 and 4 again? Because you did 2 and 6 this time, but what about 2 and 4? That would work.
I did 2 and 4 this time.
Oh, okay. I guess I'm just going crazy.
I said 6, but that's not what I meant. I meant 4. Did that answer your question?
Yeah.
Okay.
Thank you.
Right, so positive, positive, they're both positive. Positive, negative, one is negative, the smaller of the two. Negative, positive, they're both negative. So that means the last type is going to be whatever we haven't done. But let's do another example like this first. For number 8, we need two numbers that multiply to be 28, but add to be 11.
7 and 4.
7 and 4 would work. They would both need to be negative.
So smart.
I'm smart, not this class.
No, you are smart.
Yes.
I have to pay attention.
So far, do we have any questions on this? We're going to go back to the front and do 2 more problems together, and then you'll have time to practice the remaining. So go back to the front, and we'll do 15 and 16. Now we have negative, negative. For number 15, some factors of 63. I think we did this earlier.
That's 4.
That's right.
9.
9 and
6 goes down. 7.
you're close, 7. And there are others, but the others wouldn't work because they're like 21 and 3. That wouldn't give you 2. 1 and 63. That also wouldn't give you 2. But if this is negative, one of these have to be negative. Which one would be the negative?
7.
To get negative 2?
Oh, no, negative 9. But you got
Yeah, negative 9. So if you have negative, negative, one of them is going to be negative, and it's the bigger number. So b minus 9, b plus 7. For 16, what are 2 numbers that multiply to be 3?
3 and 1.
3 and 1. Which of those numbers would be your negative?
1.
To get negative 2.
Oh, 3.
It's always the bigger of the 2 when you have negative, negative. So a minus 3, a plus 1. As you're going through, before you even get answers, I would look at it and say, okay, this is plus plus or positive positive. My answers are going to be positive positive. This is positive negative, so my answers are going to be a positive and a negative, but the negative is going to be the smaller number. And go through kind of all of those. That will help you recognize which type. Of course, you don't have to do that because you could just find the factors and then determine it here. But that may also help you when you go through each problem. Anyone have any questions on this so far? I'm going to give you guys some time to work through the first page of problems. If you finish this before we move on or before we go over these problems, move on to the back so you can get additional practice. But try as many of these first. We'll be walking around. This will take 5 minutes. Starting with number 3, I'm just going to read off the factors. Make sure you have these. If you didn't get these, make sure you are trying them on your own. So number 3, h plus 3, h plus 6. Number 4, a plus 6, a plus 4. Number 5, k plus 5, k plus 1. Number 7, I think we did that one. Yes, we did. 8, x plus 4, x minus 2. 9, g plus 5, g minus 2. We did one. 11, c plus 9, c minus 5. 12, n plus 7, n minus 4. 13, x plus 10, x minus 3. 14, a plus 6, a minus 1. We did 15 and 16. 17, k minus 16, k plus 14. And 18, x minus 18, x plus 4. If you are struggling with any of this, Josh,
I'm doing the equation.
if you are struggling with any of this, have questions on any of this, want to go through this one-on-one, please come see me after school, starting today. If you still need to finish your tests, come see me after school or before school. If you said that you want to start on retake, that retake process, come see me before or after school. Because we may not have time in class until maybe next week or after.
No.